deal with, man, you wouldn't believe.
I don't even like deal with
Really
myself.
Sam.
David.
Oh, I was just kidding. You're talking about that.
I think David
Yeah.
I was mostly.
I think it was a legit statement though.
It's not.
I mean,
I would
there's
never
some.
want to be a teacher. Like putting up with me, no. Putting up with me freaking what's his name?
Yeah, okay.
Like
What district was that? Oh, that's
I
tough.
don't think it was.
she was there for like 25 years, and there was somebody there for 20 that was only being paid half as much because they stopped doing that racism.
That kind of happened here too. Just depending on when you came in.
They don't even get a pension anymore.
why is it just a gallon of milk, Sam?
It's not. You want some?
Ew.
Why is it gross though? I don't get this. It's just milk.
I mean, literally.
Probably a little more.
It's good to be sitting
You gotta find an empty bottle.
That's kind of ironic. Last
Yeah,
night,
it's not gonna be refrigerated anytime soon.
sorry,
Yeah, so you rather drink it.
put it in the
It's
microwave.
actually nice.
It's cold. It's pretty cold. It's like it's probably.
Okay, but where am I gonna get the cup?
You know, that's kind of ironic. 'Cause last
Hey,
night, I looked
Can
at
we
my
focus less on the milk and more on the problems on the board, please? Thanks in advance for your cooperation. See, when David's out here, everything gets out of control. He's not telling you to be quiet. Watch my language.
Oh my gosh. Everybody just started cussing over the recording. When he watches it, he just
Where's Jarvis? You know, there's a lot of other empty desks in this classroom available for your sitting. You wanted to move seats? Yeah, see, that would make a good angle for the viewing. I agree. If it didn't want anything to do with it, you could just sit there. Top-notch explanation. Which one? 6? So, I mean, 2 ways you can do it. I'm looking up who's considered. What? This right here is the margin of error. Like the part that's after the plus minus, the part that you're adding and subtracting, is the margin of error. So you technically don't need to know X bar. You can just figure out these things and multiply them. Or you could make up a mean and then see, like if your window comes out to, like if you made up a mean of 100, let's say. I'm talking about 6 if you're interested in a hint here. If you just made up a mean, let's say the mean is 100 that you created, and your interval came out to 98,102, well then what's your margin of error? It'd be 2. So you can make up your own mean and kind of attack it that way, or you could just do the math on this margin So confidence interval of 100, 25 could be written as, so you'd find the average of those two, so 175 plus or minus 75, it's got a width of 150, margin of error 75, and a point estimate of 175. Questions on one? Alright, as T star increases, what happens to the width? Well, if T star gets bigger, that means this number is getting bigger. And then when you multiply it, that means this margin of error is going to get bigger. And if your margin of error gets bigger, doesn't your width also get bigger? It's also the same idea that the more confidence I need that I'm right, the wider interval I want to use. If I decrease n by a factor of 9, what happens to the width of the interval? So first of all, if I decrease my sample size, does my interval increase or decrease? Like the width of it. Those are opposites, aren't they? So if I increase sample size, what happens to the width of my interval? It gets narrower. If I decrease sample size, interval is going to get wider, but it wouldn't get 9 times wider. How many times wider would it get? It would be 3 times wider. So if you make this 9 times bigger, it's inside of a square root. So it'd be 3 times, 9 times smaller. It's inside of a square root, so it'd be 3 times bigger. So if I made it like 16 times smaller, your interval would get 4 times wider, because 4 squared is 16. Okay, so this would be 3 times wide. If I want to increase the confidence level, what happens to the width? So if I need to be more confident that I'm capturing the true answer, it's got to be wider. 3 conditions. I'm not going to write them all, but you need the population normal, or a large enough sample size, which is 30, right? Or if you have a small sample, you're still okay as long as that small sample is what? That's the independent. I want to know if my sampling distribution is normal. That's always true if the population is normal, if we have a big sample size, or if our small sample that we have is approximately normalized. So those are your 3. And then margin of error here. So like I was talking about a second ago, there's 2 ways. You could have made up an x bar. Let's say x bar equals 10. And then go into my calculator and run a test. I didn't do it this way, but give me a second. And put in the information. So this is one thing that I want to get across when you're doing a lot of these problems. Let me even back up. Like, let's say I didn't know this. I'm just drawing a blank. When I increase T star, I don't know what happens. So what does that mean? I'm not sure. You can always just try it. So just make up data. So say like x bar equals 10, 90% confidence, S of x equals 8, and I'm just making up stuff, n equals 40. Figure out what that is. Increase your T star, figure out what that is. See if you got bigger or smaller. So you can always just like kind of play with the data, because you're not necessarily going to remember all the rules, but you have this, and you can just trial and error stuff. What happens when n gets bigger? I don't know. Let me try it with the bigger n and see what happens. So you can always kind of wiggle your way to the answer. So that's what I'm going for here. There's a shortcut to this, but if I don't know it, I'm just going to type in stuff. So if you make up an x bar, it comes out to 8.9, 11.1 basically. At that point, can you tell me the margin of error? So then you can just go, well, it must have been 1.1, right? You know, 1.1 this way, 1.1 this way. The other way you can do it is margin of error is this calculation. It's this part of the formula, just like the part after the plus minus. So you can just plug all this stuff in, multiply it all out, and you get the same thing. I think it's 1.06 is the right answer, right? So 1.1 is rounding a little bit. It's really like 1.06. Does that make sense? One of those 2 ways? Questions on any of the warm-up? Okay. grab a template, or if you have a blank, but I want you to do another full problem here, full process. Let's do that one. How many did you take, Shram? It's okay. You'll use them. Well, you'll be supposed to use them. I don't know if you will. So I want you to do the full process. With that. I gotta do it too. You're writing everything out. That's what I want. What?
Do you recommend like writing the problem on it?
Oh, that's not what you're asking?
Yeah.
I would always write them on the back, and then do the problem on the front, so that way when you're looking back later, you can like know what you were doing, you know? Or at least write down on the back, like, an overview of it, like what Xbar is, what SMX. You don't have to write the whole story, right? I like the Mr. Porter part. Does this part matter? Does it say that the sample data is skewed to the right? It doesn't matter why. No, it won't. So, okay, let me go to the sample data. Why does it matter? N's bigger than 40. If N's bigger than 40, I don't care what my sample looks like. If N was like 20, would this matter? Would I be able to do the problem if N were 20? Only if it's a population normal would be the only way. Okay. So I'm giving you that just to kind of mess with you and make sure you realize you're not supposed to. So now you're going to travel. Now you can get 2 seats. Double parking. take this down so I can display the answer? Does everybody have the information they need from this? Mr. Porter is a little bit skewed to the right. Thank you, sir. So there's kind of the top part. Again, you gotta check this in detail. Like everything you write, everything I wrote on here matters. So you can't just look at it and be like, oh yeah, I got most of that, I got the numbers right, I'm good. Because that could be like a 2 out of 4. So make sure you're checking it very thoroughly, asking questions if you're not sure about something. Yeah, you should put degrees. I don't know if I put that on our very first template, which is kind of my fault, but you should put it. Thank you. Yeah.
Is it okay if we had just each t-shirt considered individual?
Yes. So for independence, you don't really need both of these. You just need one of them. I'm just putting both your options here.
And then, like, instead of saying large sample, I can just put evidence greater equal to.
Yeah. You're just saying it in a different way than I am. Yeah. So yeah, like what Sarah just said too. Instead of putting large sample, you could just put n is greater than equal to 30. That's just saying the same thing, different way. Did I hand out here? Yeah. You know, it's hard to make a list of like the 10 people most likely to bring a gallon of milk to class. That makes sense to me. You know, is that right? How do you get them together? Well, because you probably spent like 2-3 hours a minute over What's your sister's name? So all that means, well, it's fine, but then you gotta, Good. Like, I just do mu because that's like a shortcut. There.
Yeah.
But as long as
That's
you,
what I thought. I didn't think it would be that big a deal with it.
you're good. As long as you say it again. So here's the. Can I like slide it down? Everybody good with that top part? Here's the rest of it. You do want to put degrees of freedom. I don't think I remember to put this on like your initial template that we did. But make sure you put that. That should be there. My bad. If I put that, I forgot.
You say like something is independent.
Yeah.
You just say it's independent, or do you have to be like considered or
It's, you should put like can be considered or wasted. Is the best thing to do. If you just put is independence, I think it's probably okay. But it's a little better. So some of the stuff, have I talked about like how they grade for response questions yet? How there's like a middle ground. I don't think I have. When they grade them, the free response questions are on 4, and there's no decimals, which is bizarre to me. Like I don't understand why they gave you a 3.5. But so they'll grade it and they have this rubric, and each part will be considered essentially correct. So like they would look at this whole process and break it out into parts, and they would each part would either be essentially correct correct or incorrect. Essentially correct is best, partially is kind of, incorrect is no. And they go through each of those. And they're like, okay, you got that part essentially. And then at the end, they look up this rubric, and it's like 2 E's and a P give you a 4. Or 2 E's and 2 P's give you... But then there's this like way they get to a number. If they get to a decimal, which happens a ton, what they do is grade... Okay, so let's say you get 3.5. They look holistically to see if you get a 3 or a 4. They won't give you a 3.5. So I'm at this conference, I raise my hand, I'm like, what does that mean? Like, tell me, I don't know, like, what are you looking for holistically? And they like rambled for 5 minutes and didn't say anything. I literally raised my hand and I was like, so what does that mean? And they really like can't tell me. So like a lot of the things that you get to, you're gonna get like a 3.5. But then so like Sarah just asked, should I write can be considered independent, or is it okay to just write each teacher is independent? The little things like that are what my best guess is that'll take you. When you have 3.5, are they going to bump you to 4 or drop you to 3? Like, so kind of these little things aren't necessarily worth points, but they'll bump. Does that make sense? I'm trying to get at? I don't know why they can't just give you 3.5. It's ridiculous to me. It's a freaking math test, but no one asked me. So. Anyway, questions on this stuff? How many feel good about that process? Okay. All right, let's take out the sheet in front of you then. So get a little more into like the concepts. What? Is that?
Yeah, we're fine.
On this sheet, so circle all that are true. Remember these, so we're kind of really getting into the bottom section here. We've broken down the conditions, right? Broken down the math box. We're going to break down the conclusion a little bit. And what's the goal every time we do this? We're trying to make an interval that does what? Captures the population mean. That's what we're looking for. So I want you to try to circle all that are true. You're looking for it to capture the true mean. There are 5 circles. You should circle 5 of these 11. I want you to try to pick out the 5 of these statements that are true. And some of these, like when you get to the end, this is where you test if you need to. You know, what's the smaller sample size? Okay, well, let me make up confidence, or we'll try a smaller sample size. See what happens. SX bar is
No, it's 2. Standard deviation.
SX bar is the standard deviation of the sample.
How do you solve it?
So it'll be 2 over square root.
Wait, I'm so confused. Which one are we looking at?
Always. I'm just trying to find essence. Because I think I need them, and I don't know if you can find it. And maybe I don't.
I don't think you need. So the situation up top is just like to give you a general starting point. These statements should all be true or false. Like I don't think you're doing any calculations really. Which one are you looking at that you thought you would need that? I could be wrong.
I don't know. I just thought I needed it.
I don't think you do. But if I did, it would be 2. No, sorry. Oh, I didn't even give you the right information.
Yeah, because I only found 2 of them that were 2 and 10.
Well, that might be a different issue. 2 and 10?
Yeah, 2 and 10 and 7.
2's not true.
Wait a minute.
Okay, ignore everything I wrote up top. That's not really what. I think you're focusing on the wrong thing. You get a. I'm trying to guess population mean ACT score. I take a sample of 20 people. No, what did I say? 4 people. Okay. And I find this is my confidence interval. Forget the rest of it. I'm telling you it's between 15 and 19. I'm 95% confident or whatever it is that the mean ACT score is between 15 and 19. Based on my one sample. Then, with that information, try to find 5 that are true. 2 is not true because I don't care where future sample intervals lie. I care where the population mean is. I feel like I should have said this part 5 minutes ago.
I just been staring at this.
Does this help you not just stare at it? Okay. You have 4? Which 4?
4, 7.
Wait, I have
7, 10.
not circled a single one.
1, 7, 10, and what?
None. Wait, thank you for giving me all the answers.
3 is not true.
I don't know if those are right. I'm just not even
There's no
The other one's debatable because it's kind of what I just changed. No. But if you erase the 20, the number 5, then it's real. So let's just talk through them. I'm not sure I presented this as well as I could have. So, I mean, this is kind of on me, I think. But number 1 is true because we're 95% will contain the true mean. If you see the phrase contain the true mean or capture the true mean, that's gold. Like, that's what they want. So there's 3 or 4 multiple choice in this packet also from AP tests, and you'll pick up on that same thing. You want capture the true mean or contain the true mean. Number 2, this talks about, like, containing future samples. I don't give 2 craps about a future sample. I care about the actual population mean. You know, my sample in this room, and Porter's sample in his room, and Kraft's sample in his room, and those are all separate, those are all different. I don't care about theirs. I care about the actual population answer. Number 3, that doesn't talk about the true mean at all. So it's not interesting to me, it's not relevant, I don't care. That's not true necessarily. Probably true that the true mean is 17. Our sample would lead us to believe that, but is there anything special about our one sample that makes our one sample better than any other sample? There's not. So like another sample, like Kraft takes a sample across the hall, might come out to 16 and 20. Is his better than ours? Not necessarily. So again, I'm trying to capture the true mean somewhere in this interval. I can't really say like, I think it's this. So that one's no good. Number 5, if you erase the of 20 at the end, which again is kind of on me for phrasing these not the greatest. But now that I've erased that true? That's phrased like ideally. So we're trying that would capture the true mean, contain the true mean. That's what we want. Number 6. Again, that's just based on my one sample. My one sample is not special. I'm trying to guess the population mean. This doesn't talk about the population mean, so I'm not interested. Alright, then we get into like, okay, what if this gets bigger, smaller, whatever. And again, you can just try these. Like if you want to just put data into your calculator, run the test, change the data to what the question says, run the test again. It's a perfectly valid way to do it, but a larger interval. So if I make my interval larger, am I more confident that I'm capturing the true answer or less? More. More. So 7 is true. Number 8, a lower confidence level would increase my margin of error. Well, lower confidence level means I'm going to be less confident that I'm capturing the true answer. So if I'm less confident, my interval gets narrower. And if my interval gets narrower, what happens to my margin of error? It gets narrower also, right? So that one is not true. Number 9, if I increase the confidence level, I need to be more confident that I'm capturing the right answer. So what happens to my interval? I need to be more confident. It's going to get bigger. If I have a bigger interval, do I have a smaller margin of error? No, I have a bigger. Right? Decreasing the confidence level will decrease the margin of error. Decreasing the confidence level means I'm not really quite as sure that I'm right. I'm narrowing in. I'm trying to be more precise, which means I'm going to be wrong more often, but it's a smaller window. And if I have a smaller window, what's true about the margin of error? It's smaller. Like the margin of error is just like that half, right? So if your window gets smaller, it's pretty good. It's like a half. See how the margin of error gets smaller? 95% probability, so that's because it's 95% confidence. And again, we're looking at the true mean. So does the true mean lie between those two numbers? Now that we've got, I don't know if that presented that the best way, but now that we've gone through it, does that make some sense? You should get it now.
Yeah, it makes sense. Well, for the last one, does the 95% mean like for every sample you do, like every individual interval there's a 95% chance that interval contains the true mean? So it's not like
It's like over the long run, if I did it a billion times, 95% of them would contain the true mean.
So all I'm saying is it's not the 95% chance it's in between those two numbers. It's a 95% chance one of the intervals would contain it. That's all I'm.
It's a 95% chance for each interval.
Okay. That makes more sense.
Okay, is that better? Okay. Any other questions? Okay. Try the. Let's go. Just try the next page. We'll kind of take this a little bit at a time here. So the 3 multiple choice on the next page. These are from actual AP tests. You guys all got it once, or did you like slides on it too?
Yeah, they said 50 minutes. I stopped at 53 minutes. People were still going.
This says 50, but people were still going at
53. I mean,
Really?
I didn't read it. I was reading. I had finished. I was just reading through my
and they didn't like stop anybody.
No, so it's not super strict.
I guess not.
David, is everybody already done with it? No, there are still a couple people there. That's it for scholarship.
Trying to do the recommendation, so I have all the names clicked, which is nice because it looks like you don't have to.
You can
go
do them all
person
at
by
once.
person. But, yeah,
I haven't done it yet. I don't have very many to do.
so I went to there.
Oh, I've never done that.
Maybe you can do it this way.
Maybe it's a new one.
So then I did create recommendations.
Well, that lists who you have. Okay.
So then I picked like my 3 integrated classes. And then put
Oh,
down,
then you can scroll
then
down.
down here you can click on who you want. But then when it got to the course, like I know the course is like 1 MTH 801, but I can't get it to show up like when I type it in the box. I don't know why that's.
Just plus.
Hit apply and like nothing.
You tried that?
Yeah, I just can't get anything to show up. Which I thought, oh, that would be nice to just click a bunch of boxes and do it
Really
once
nice.
instead of having to. But maybe you can't do it that way. I mean, you would think. It's got to.
Looks like perfectly designed for that. What about if we do like course? Like it should pop up.
Yeah, that's what I would think. Something should be populated. I don't know how to.
It's over at the corner. It looks like this on the front.
I was doing that. She's done it yet.
Yeah, no, you're good. I mean, you're still responsible for the stuff. But
Yeah,
you're good.
they're gonna. Yeah.
Yeah, okay. So I used to go in this way. But that's changed. So
See if
figure out
that even
another
shows
way.
up on here. Maybe it's called something else then.
And then you gotta do it for both semesters, which is interesting.
You can hit submit.
And then you gotta do it again. She's already in the class. I'm not gonna do it with that. So yeah, you go there and hit submit. And then
There should be a way to still hit recommendation and do it. Like, how, it's like it's designed for it.
it seems like it, yeah. You guys good with these 3? Yeah? 15 should be D. How many D there? Nice. So that, the key phrase there is what? Contains the true meaning. 20 should be D. So if I want to decrease the margin of error, if I want to make it like a smaller window, try to get more precise, I need a bigger sample. And then 37 is A. You need to be more confident that you captured the right answer. So great, this makes you more confident. I'm less precise now. You know, if I tell you to guess tomorrow's high temperature, or you get kicked out of school, are you going to give me a wide interval or a precise one? A really wide one. Yeah.
So since we're saying like we're estimating for the true mean of like when we do it, we say we estimate for the true mean of
The population.
yes. In 15, would it not? How is it not? It says all random samples.
How's it not? Which one?
How is it not B?
B. 90% of all students spend between this and this. I don't care what they spend between. I care about the true mean.
Okay.
I'm looking for like, I want to capture the true mean.
Okay.
And so that also would give the idea that like our sample is not anything special. If he did a sample in his class, it might be slightly different numbers, and it's not necessarily 90%. Let's say the true mean is there, and my window is here. Well, that window is actually like a normal distribution. And if I look at, you know, if this were the true mean, I forgot the numbers, hold on. 3.45, 3.45 might be there, and 4.15 might be there. And if my normal distribution were right on top of that, yes, 90% would contain it. But my sample's like a little bit off. So this right here in my sample is not 90%. And it might be, it might not, but we're just trying to get the mean. Is that fair enough? Is that good? All right. Any other questions on that page? DDA, how many have DDA? Nice. Anything I can help? Do the next page. 3 more, and then we'll finish the rest of them on there. Well, they're doing it on purpose. There's a reason they're doing it, right?
Right.
Like, do you know you added n minus 1? Like,
Well, I can cross off A and B then.
for which one?
Great. You just strike one. Did you just say?
No,
I
and
hadn't read the problem.
the formula has n.
Oh,
Degrees of freedom is n minus 1.
I haven't even read the problem yet, so.
Is another perfect example of if you don't know what happens, try it. Like you have a calculator there that will give you confidence intervals. Make up a confidence interval with 9,000 viewers. Make up a new one with 1,000 viewers. See what happens. So you can test a lot of this stuff. Really, I don't have time to go through them properly right now, so we'll do it on Monday. No homework. I want you to do these with me, not on your own.